Good morning, my viewers all over the world. This is your regular host, Valentine. Today, we'll be doing a quick revision on prime numbers. Although our focus today is more of HCF and LCM. I repeat, our focus today is HCF and LCM. HCF means highest common factor, and LCM means lowest common factor. Or let's say we've discussed about prime numbers in the past. So this is just to do a quick recap. Because from what I noticed is that topics on HCF and LCM has a link. It has a link between, it's linked to prime numbers, multiples, and factors. So we need to know these three essential topics before we can delve into HCF and LCM. So let's quickly do a quick recap of what our prime numbers are. So for start, a quick summary of everything we see on our screen. A quick summary is that prime numbers, a prime number is a number that is divisible by itself and 1. In summary, what it simply means is prime numbers have two factors. A prime number has two factors. A prime number has two factors, itself and 1. Take for example, we say 7 is a prime factor because the only two numbers that can divide 7 without remainder is 7 and 1. It's 7 and 1. I repeat, the only two numbers that can divide 7 without a remainder is 1 and 7 itself. Hence, 7 is a prime number. Again, we can say 5 is a prime number. Reason: 5 can only divide 5 without a remainder, and 1 can divide 5 without a remainder. So these are some examples of prime numbers. I repeat, the prime number is a number that is only divisible by itself and 1. But remember, 1 is not a prime number because I've seen a situation where I was asked, is 1 a prime number? Please take note, 1 is not a prime number. Reason: it has only one factor, which is itself. 1 is not a prime number because it has only one factor, which is itself. So let's move on to the next slide. Now we need to understand what multiples are, factors, and prime factors. First thing, we'll say multiples are just like our times table. For instance, we say, what are the multiples of 2? The multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, and so forth. So if you watch, this is just like a times table on this, just like a 2 times table. For instance, 2 times 1 is 2, 2 times 2 4, 2 times 3 6, 2 times 4 8, 2 times 5 10, 2 times 6 12, 2 times 7 14, 2 times 8 16. So in summary, our multiples are like our times table. For another example is, let's take 3. So what are the multiples of 3? 3, 6, 9, 12, 15, 18, 21, 24. So if you watch 3 times 1 is 3, 3 times 2 6, 3 times 3 9, 3 times 4 12, 3 times 5 15, 3 times 6 18, 3 times 7 21, 3 times 8 24. In summary, these are all the multiples of 3. Then we need to look at what are factors. We say factors are a set of numbers that can divide a particular number without remainder. I repeat, factors is a set of numbers that can divide a particular number without remainder. So let me clean this so I can make space for more explanation. I repeat, factors are a set of numbers that can divide a particular number without remainder. Take for example, if you ask what are the factors of 12? The factors of 12 are 1, 2, 3, 4, 6, 12. So all these sets of numbers 1, 2, 3, 4, 6, 12. All these numbers can divide 12 without a remainder. As such, these set of numbers are all factors of 12. Let's take for an example, what are the factors of, let's say, 15? The factors of 15 are 1, 3, 5, 1, 3, 5, and 15. So this set of numbers can divide 15 without a remainder. As such, they are all factors of 15. At this point in time, we've been able to differentiate what a prime number is, what multiples are, and what factors are. So the next thing is we need to look at what are prime factors. Prime factors. So if you watch this keyword, prime factors, we've talked about what prime numbers are and what factors are. So if you combine both the words prime factors, we've looked at what a prime number is and what factors are. So combining those two words, combining prime and factors will give us prime factors. And such, we'll say prime factors are a set of prime numbers that can divide a particular number without a remainder. I repeat. Let me see if I can write it down. So we say prime factors. So let me shorten this. So this is prime factors, a set of numbers, set of prime factors are set of prime numbers. So we need to be explicit. A set of prime numbers a set of prime numbers that can that can divide that can divide a number without a remainder. Without a remainder. I repeat, you say prime factors, a set of prime numbers that can divide a number without remainder. So in essence, we've been able to dissect what a prime number is, multiples, factors, and prime factors. In summary, we said prime numbers are numbers that can divide itself and 1. Remember, 1 is not a prime factor. In summary, as such, 1 is not a prime number. Let me repeat. A prime number is a number that can only divide itself and 1. In essence, all prime numbers have two factors, itself and 1. Remember, 1 is not a prime number. 2, we've talked about what multiples are. Multiples are just like our times table. I've shown you the examples. Then we looked at what factors are. We said factors are a set of numbers that can divide a particular number without a remainder. Then we looked at what our prime factors are. We said prime factors are a set of prime numbers that can divide a number without a remainder. Then that leads us to how to find our prime factors. To find our prime factors, there are two ways to do that. One, we call that the factor tree. One we call the factor tree, which is this, or this method. These are the two common methods to find our prime factors. So from experience, I notice the factor tree is more easier. So let's stick to using the factor tree method because that is what I've noticed that most of my learners prefer to use. So let's stick to that using the factor tree. So what's the factor tree? For example, we are told find 420 as a product of prime factors. Express 420 as a product of prime factors. So what we just needed to do is to get 420, then split it into factors. So we need to think of two numbers such that if you multiply them, you will get 420. And it's at the same time be the factors of 420. So for example, the factors of 420 is 42 and 10. Because this is 42 and 10, you don't stop here. Remember, we are trying to get the prime factors of 420. And we said prime factors are a set of prime numbers that can divide a particular number without a remainder. So 42 and 10 are not prime factors. So therefore, we need to go further to break it down. So the factors of 42 is 6 and 7. Reason, if you multiply 6 and 7, you will get 42. But we don't need to stop here. But look, if you look at, we've gotten one of the prime factors of 42, which is 7. So 7 is a prime factor because apart from dividing 7 and 1, there's no other numbers that can divide 7. So 7 is a prime factor, but 6, you notice that we cannot stop at 6 because there are still numbers that can divide 6. So 6, you don't stop here. Then we look at the two numbers that can divide 6, the two prime factors that can divide 6 without remainder is 2 and 1. I'm sorry, 2 and 3. You can say 2, 3. Then we'll come to 10. 10 is not a prime factor. So we need to split these two. So this is 2 and 5. In summary, 2 and 5 are the only two prime numbers or prime factors that can divide 10. So in summary, 420, the product of the prime factors of 420 are 2 times 2 times 3 times 5 times 7. In summary, these are the prime factors of 420. In essence, these numbers, these prime factors, otherwise known as prime factors, can only divide 420 without a remainder. So let's move on so as to appreciate what we'll be talking about. Now let's look at this as an example. We're told to write 280 as a product of its prime factors. Write 280 as a product of its prime factors. Give your answer in index form. Give your answer in index form. So we need to be conscious and pay attention to details. So let's start using the factor tree method, which is the most common one. So this is a factor tree. It's 280. Then we think of two numbers. We split this that we think of two numbers such that there are factors of 280. So let's settle for 28 and 10. Because if you multiply 28 by 10, you get 280. You don't stop here. Remember the key point. We are looking for the prime factors of 280. We don't stop here. So we'll break further. So let's think of two numbers that can multiply to give us 28. So let's say 14 and 2. Because 14 times 2 will give us 28. So 2 itself is a prime factor. We'll stop here. Then we'll look at 14. So we need to go further. 14 is the two numbers that can divide 14 are 2 and 7. You can see these two numbers are prime factors. So we'll stop here. Then we look at 10. You don't need to stop at 10. You think of two other numbers. So that would be 2 and 5. So 2 is a prime factor, 5 is a prime factor. So in essence, the prime factors of 280 are 2 times 2. How many 2's? 1, 2, 3 times 2 times 5 times 7. So these are the prime factors, but we need to look at the concluding part of the question. The concluding part of the question says, give your answer in index form. So what this simply means, you put this in index notation. So in essence, your final answer will become 2. How many 2's do we have here? 1, 2, 3. Raised to power 3 times 5 times 7. This is our answer. So for simplicity's sake and time's sake, so I will leave these numbers, these other questions for my learner to have a go at it. So this has been solved. Please go through the examples of what we did, and this will help you solve this question 3A and B. So let's see the answer on the other side. You can see this is the answer, and we are correct, 100% correct. So let's move on. Now, this is the main cross of the matter, which is LCM and HCF. We say our LCM, this is LCM and HCF. Our LCM is lowest common multiple, and our HCF is highest common multiple. So, first method, there are other ways to do this. So, I will show you the two ways, and you can settle for the method you feel is more comfortable. So from this word, from each word, it's the lowest common multiple. Lowest common multiple. LCM, lowest common multiple. This suggests what you need to do. So what they are trying to say, the lowest common multiple saying, get these two numbers, get the multiples of 12 and 15, then you look at the lowest common one. That's the lowest common one between the two numbers. I repeat, the LCM of 12 and 15. The first step is with what it's trying to say from its meaning suggests what you need to do. Lowest common multiple. What it simply means is find the multiples of 12 and 15, then pick the common multiples between the two numbers. So, for instance, the multiples of 12 are this. Remember I said multiples are like our times table. So multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96. So if you notice the other way around, if you notice you keep adding 12 to it. So 12 plus 12 will give us 24. 24 plus 12 will give us 36. 36 plus 12 will give us 48. 48 plus 12 will give us 60. 60 plus 12, 72. 72 plus 12, 84. 84 plus 12, 96. Then you look for the multiples of 15. So the multiples of 15 are 15, 30, 45, 60, 75, 90, 105, and so forth. So if you notice, 60 is 60, the number 60 is common between 12 and 15. So the lowest common multiple of 12 and 15 is 60. You can see the lowest common multiple of 12 and 15 is 60. Then you single it out. So the low LCM of 12 and 15 is 60. The other method you can see, I don't want to delve much on this. I believe this might be a little bit confusing. So let's stick to this. This is more well explanatory. Then we look at the highest common factor. So the question says find the highest common factor of 36, 54, and 72. As usual, so we need to get the factors of 36. What it simply means is we can see the difference. Find the highest common factor of 36, 54, and 72. What this simply means is you pick 36, you list all the factors. Remember, we said factors are a list or set of numbers that can divide a particular number without a remainder. So we need to list all the factors of 36. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. Reason, all these set of numbers can divide 36 without a remainder. As such, they are the factors of 36. Then we'll pick 54. We list all the numbers that can divide 54 without a remainder. So we pick all the numbers that can divide 54 without a remainder. So the numbers are 1, 2, 6, 18, 2 is there. Then you pick 72. You look at all the factors or numbers that can divide 72 without a remainder. So these numbers are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. So all these numbers are factors of 72. I repeat, the meaning of the acronym HCF, highest common factor, depicts or shows or tells you what you need to do. So once you've done that, you pick the highest common number between the three, which is 18. 18 is a common factor of 36. 18 is a common factor of 54. And 18 is also a common factor of 72. As such, you pick them out. So the highest common factor of 36, 54, and 72 is 18. So no need of showing this because this might be a little bit complicated. Because of time, I won't want to talk about this. So we need to go for the simpler method that is well explanatory. I repeat, the words, the meaning of the acronym HCF, highest common factor. Pick the numbers, list their factors, then pick the one that is common between you might be given two numbers or three, then you pick the highest common factor between the numbers. So let's look at an example. So let's look at this. Because of time, maybe we'll be looking at this number, then we'll be looking at these two. So this one, I will encourage my learners to have a go at this question. So let's look at this number 1A. So maybe probably we'll look at 1A and B. So let's go ahead. We said from the box above, choose two numbers that have a common factor of 10. Remember, we said factors are a set or list of numbers that can divide a particular number without a remainder. So choose two numbers that have a common factor of 10. So this should be 40 and 100. 40 and 100. Reason, 10 can divide 40 without a remainder, which is 4. And 10 can divide 100, which is 10. So these two numbers are correct. Then the next one says two numbers that have a common multiple of 24. So what they are trying to say is what are the two numbers that have a common multiple of 24? So remember we said multiples are like your times table. So for this, we'll settle for 6 and 12 because 24, 6 times 4 will give us 12 and 12 times 2 will give us 24. 6 times 4 will give us 24 and 12 times 2 will give us 24. So this, or put in another way, the multiples of 6 are 6, 12, 18, 24. Multiples of 12 are 12, 24. So this is correct. So let's move on with this one. See, two numbers that have a common factor of 7. So we look at this, that will be from this list of numbers, that will be 28 and 35. 28 and 35. Then we look at this other one, have a common multiple of 200. So from this list to still be 40 and 100. So these are the correct answers. So then we'll move on to these. The question says find the lowest common multiple of 12, 14, 21. So to do that, we need to list LCM, lowest common multiple. So we need to list the multiples of the numbers. We need to list the multiples of the numbers. So let's see. The multiples of 12. Remember we said multiples are like our times table. So the multiples of 12 are 12, 12, 24, 36, 48. If you add 12 to this, you get 60. You add 12 to this, you get 72. You add 12 to this, you get 84, and so forth. Then we look at 14. We need to list all the multiples of 14. So we begin with 14. You add 14 to 14 give us 28, 42, 56, 70, 84. The next one is 21. We are trying to list all the multiples of 21. So that will be 21, 42, 63, 84, then 96, and so forth. So if you notice, we've gotten a common multiple of 12, 14, and 21. So the common multiple, the lowest common multiple of the three numbers is 84. So this answer is equal to 84. So I will encourage my viewers or learners to have a go. So this is find the highest common factor of 36 and 84. If you still don't understand how to find your common factor, you can look at the previous slides. We've talked about this. That will help you solve this. Remember, all these are a bit to help you to learn how to solve questions. And remember, all these are just a quick guide to make you or to deepen your knowledge of LCM and HCF. Remember, this is a quick revision guide. This is a quick revision guide, and I will encourage my learners to do their research, to create time for homework. Then you can use this to complement your studies and knowledge. Then the next question we need to look at is this. We are already given this. We'll be given the prime factors of 112 and 140, and we are told to use it to find the HCF, meaning find the highest common factor of 11 and 112 and 114. So for space, okay, we can use here. So this is 112. You can see it has been done already. So this is 2 raised to power 4 times 7. So what we just need to do, we need to split it. So 2 raised to power 4 means 2 times 2 times 2 times 2 times 7. Then we look at 140 is equal to, it has been given already. So that's 2 times 2 times 5 times 7. So what it simply means is 2 raised to power 2 is same thing as 2 times 2 times 5 times 7. So we need to look for the HCF. To look for the HCF is, remember, HCF means highest common factor. Highest common factor. Highest common factor. And we'll be given the prime numbers of the list of prime numbers. So we need to look at this. 2 is 2 here, so this is common. You circle it. This is also common. You circle them. So what's common between these again? 7 is common. So therefore, the highest common factor of 112 and 140 is 2 times 2 times 7. So 2 times 2 for 4 times 7 will give us 28. The final answer is 28. Okay, I'll leave this for my learners to have a go. And if you have any questions, you can always reach me through my comment side or my comment section. I'll be able to answer your questions. Then let's see the answer slide. You can see we are correct. All this correct. Then there's 2. You can see we solved this. This is correct. And we looked at this. This is correct. So I will encourage my learners, please go through the slides, have a go with the questions, go to the answer slide, and cross-check your answer. As we approach the exams, I believe the national exams is just 2 months away. I wish all my learners, my viewers, the best of luck. Always remember, keep practicing. The more you practice, the more you get better at whatever you do. Keep practicing and see you at the top of your success career. Thank you and thank you very much. This is your regular host, Valentine, and see you in the next session. Thank you. Bye.